So now we're going to move from statistics into probability, which is all about how likely something is to occur. What's the chance of something happening? We're on page 119 in your notes, so take a moment, get your notes out, open to page 119. Probability. Probability is a fraction that tells us how likely an event is. Probability is a fraction that tells us how likely an event is. Probability is a fraction that tells us how likely an event is. Get that one copied down. The calculation we're going to do, it's going to be a fraction, so I need a numerator and a denominator. The numerator is going to be the number of winners, and the denominator is the total number of outcomes. The numerator of my fraction, I promise I'll show you exactly what this means in just a moment, but for right now, get it copied down. It is the number of winners over the total number of outcomes. And then I want to write 3 more things about probability. If we change our fraction to a decimal by dividing the top by the bottom, it will always be a number between 0 and 1. The probability as a decimal is always between 0 and 1. Get that one copied down. The closer our probability is to 1, the more likely it will occur. The closer our probability is to 1, the more likely it will occur. I'm going to write one more thing and then I'm going to pause so you can get all this copied down. The closer our probability is to 0, the less likely it will occur. And I'll pause in just a moment so you can get caught up. The closer our probability is to 0, the less likely it will occur. Okay, I'm going to make the video pause, get all that stuff copied down. So I want to show you a whole bunch of examples. First one, we're going to spin a spinner, this spinner over here. And I want to find various probabilities. Part A, I want to find P of A, which is fancy notation, kind of looks like our function notation actually. Fancy notation that says this is the probability of getting an A. Take a moment, get that copied down. My answer is going to be a fraction. The numerator is the number of winners. How many winning spaces do I have that are A? Well, 1, 2, 3. My numerator is 3. My denominator is the total number of spaces here. 1, 2, 3, 4, 5, 6, 7, 8. My denominator is 8. My answer? 3/8. That's all. Count the number of winning spaces, make that the numerator. Count the number of total spaces, that's the denominator. Letter B. Let's find the probability of spinning a C. I think you can go do that. Go find the number of winning spaces over the number of total spaces. Winning spaces here, I've got 1, 2. Total spaces, you know what? That hasn't changed since the beginning. That'll never change since the beginning. There are still 8 spaces, so my probability is 2 over 8. However, what do we have to do here? It's a fraction. You always need to simplify your fractions. 2 and 8, I think I can divide them both by 2 because they're even numbers, and I'm going to get 1/4. I'm just going to add in a little note that says always simplify. Now, I think I said that we should give these as fractions, but I did make a comment about them as decimals. If I change these into decimals by dividing the top by the bottom, first one is 0.375, second one is 0.25. I think this is the bigger number, which means this one's more likely to occur, and this one's the smaller number, this one's less likely to occur. That's how we can kind of use the decimals to compare our probabilities. Part C, I want to find the probability of getting a B or a C, and I know my denominator is still 8. How many total spaces either have a B or a C on them? Okay, I'm going to start counting here. I've got 1, 2, 3, 4, 5. I'm thinking 5 out of 8, and there we go. Letter D. Let's find the probability of getting anything but a C. Some letter that is not C. And I know there are still 8 total options. Well, how many spaces have something that's not C on it? Let's see. 1, 2, 3, 4, 5, 6. I think there are 6 over 8. And what are you really going to tell me for the answer? Hopefully you're really going to tell me 3/4. One more on this page. Let's find the probability of getting an M. Any thoughts on this one? There are 8 spaces total. How many have an M? Oh, wait a minute. I don't see any M's there, which means my probability is 0 over 8. And what is 0 divided by 8? 0. That's how that one works. Let's look at a couple other situations. Let's roll a die, let's flip a coin, let's pick things out of a box. Turn the page. Let's say we flip a coin. What is, part A, the probability of getting heads on a coin? What's the probability if I flip a coin, I get heads? Well, coins, remember, hopefully, have 2 sides to them. Heads and tails. You know what, that's not a great one. Let me see if I have a penny, because that might show up a little bit better. Maybe a little bit. You see Abraham Lincoln there, that's heads. The other side with symbols and stuff like that, that's tails. What's the probability if I flip a coin, I get heads? Well, I think there are 2 sides to the coin. How many sides are heads? 1. My probability, just 1/2. Part B. How about you go find the probability, if I flip a coin, of getting tails? Again, 2 sides to a coin. 1 side is tails. You've got an equal chance of getting heads or tails. Next example. What if we roll a die? Let me see if I can find one around here. No, maybe not. Yeah, maybe not. But I think you know what a die looks like. It's just 1 dice. And I have 6 sides to my die. 1, 2, 3, 4, 5, 6. Roll a die, come up with any of those numbers. Part A, what's the probability of rolling a 3? Roll a die, what's the probability of rolling a 3? There are 6 different things that could happen. I could get a 1, a 2, a 3, a 4, a 5, or 6. How many of those sides have a 3 on them? Just 1, which means my probability is 1 over 6. How about you try to figure out the probability of rolling a 5? What's the probability of rolling a 5? 6 outcomes there. One of those outcomes has a 5 on it. I think it's just 1 out of 6. I think I might have just said 5 a moment ago. I didn't mean that. 1 out of 6, not 1 out of 5. Probability of rolling an even number. Probability of rolling an even number. Well, how many of these numbers on the die are even? 2, 4, 6. I'm going to say 3 out of 6. Oh, you know what? No, I'm not. What am I really going to say? Not 3 out of 6. I'm really going to simplify that too. Divide by 3. We're going to say 1/2. Part D. The probability of getting a number that is less than 5. A number that is less than 5. See what you can do here. Still have 6 numbers. How many of these numbers are less than 5? Well, 1 is, 2 is, 3 is, 4 is. I said less. I didn't say less than or equal to, so 5's not going to count. So I think I have 1, 2, 3, 4. 4 out of 6. That's going to give us 2/3. Probability of getting a number less than 5, 4 over 6, which is 2/3. There are 2 words that are going to show up in the homework that I think we need to talk about. Prime number. The probability of getting a prime number. A prime number is a number that we can only divide by 1 and itself. Can divide by only 2 numbers. 1 and itself. Maybe take a moment and copy that one down. 6 is not a prime number because I can divide it by 1, I can divide it by 6, but I can also divide 6 by 2 and 3, so it doesn't count. 5, though, 5 is a prime number. 4, not a prime number because I can also divide 4 by 2. 3 is a prime number. I can divide 3 only by 3 and 1. 2 is actually the only even prime number. I can divide it by 2 and 1, and that's it. 1 doesn't really count because I can't divide it by 2 different numbers, only one number, only by 1. I have 3 prime numbers over here. You're going to get 3 over 6, which is just 1/2. The opposite of a prime number is a composite number. And composite numbers are numbers we can divide by other things besides 1 in itself. 1 still doesn't count. 2's not composite, it's a prime number. 3 is not composite, it's a prime number. But 4 is composite because I can also divide 4 by 2. 6 is composite. I can also divide that by 2 or 3. I think there are 2 answers here out of 6. We'll simplify that, and we're going to get 1/3. Don't worry too much about the prime number thing. It'll show up in, I think, one homework problem, and we'll talk about it when I see you in class. But that's the idea with that one. Last one, and then we'll do some practice. Pick a candy. What is, well, I've got to give you information about these candies. Let's say I have 4 red candies, 3 orange, 2 pink, and 1 yellow. Get that copy down, please. I want to find the probability of picking an orange candy. First of all, how many total candies are there? There should be 10. How many of them are orange? I think we've got 3. We're going to make the probability of picking an orange candy 3 out of 10. The probability of picking one that is not yellow. Well, what do you think? How many candies are not yellow? 4, 3, 2, 7 plus 2. I think we have 9 candies that are not yellow. I'm going to say 9 out of 10. Letter C, the probability of picking one that is red or pink. See if you can do this one. Red or pink, I've got 4 plus 2, I've got 6 candies that are red or pink, 6 out of 10. But don't leave it like that. Simplify your fraction. We can divide by 2, and we're going to get 3 over 5. D, probability of picking a purple candy. What's that probability? Well, there aren't any purple candies, 0 out of 10, and I can simplify that to just 0. We're going to do a little bit of practice. Please take out that sheet that asks, why are oysters greedy? And we're going to find a couple probabilities. Actually, I think what we're going to do is I'm basically just going to call out a letter, and you're going to go do it. Take a look at the cards over here, and go do letter E. What's the probability of picking a striped card? Well, there are 12 cards total. There are 4 striped cards, 4 out of 12, and I'm going to simplify that to 1 out of 3. What's the probability of getting a shaded card? See 3 shaded ones over there. That's 3 out of 12, and I can simplify that to 1/4. Make sure you're simplifying all of these. Okay, what's the probability of getting a white card? I think that's 4. Wait, hold on, I counted wrong. 1, 2, 3, 4, 5 out of 12, which can't be simplified. How about a card numbered 10? I only see one card with a 10 on it. That's 1 out of 12. How about a striped or a shaded card? 1, 2, 3, 4, 5, 6, 7. I think 7 out of 12. We'll do it over there. How about white or striped? One, 2, 3, 4, 5, 6, 7, 8, 9. I'm thinking 9 out of 12. Oh, but we can simplify that, divide by 3, and we'll get 3/4. How about white or numbered 5? 1, 2, 3, 4, 5. Then I have the card numbered 5. I think that's going to give me 6 out of 12, which simplifies to 1/2. What about letter R? 3 or numbered 9? I think there are 2 cards numbered 3 or 9, so 2 out of 12. And we can simplify that to 1/6. Let's try the bottom. Read that problem, please. And try the first one. Find the probability of spinning a striped space. 10 spaces total. How many are striped? 1, 2, 3. 3 out of 10. How about white or shaded? 1, 2, 3, 4, 5, 6, 7. I am thinking 7 out of 10 there. How about striped or numbered 7? 1, 2, 3, 4. 4 out of 10, but don't tell me that simplify because they're both even. And we'll get 2 out of 5. Letter Y. I see 2 cards numbered 3 or 6. That's 2 out of 10. That'll give me 1/5 when I simplify. Letter S, numbered 4. I see 1 space out of 10. 1/10. Not numbered 4. I see 9 spaces not numbered 4. That's 9 out of 10. How about F, not shaded? Let's see, I've got 4 that are shaded. That means 6. 1, 2, 3, 4, 5, 6 are not shaded. 6 out of 10. That's going to give me 3/5. Okay, last one, either striped or shaded or numbered 7. Okay. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 spaces out of 10, and you're going to tell me 4/5. When you submit your notes for today, make sure you get the 2 pages in your book and this sheet. However, on the back of the sheet, there are some more problems, and if you do those, you can get some extra credit in this class. So if you submit those as well along with your notes, you can get a point or 2 extra credit on this. And I think that's all I've got here. See you later.